All right, here's the four-step process for solving sample and distribution of sample means. First, identify the problem. Remember, it's ICCI. Identify the problem. C, what are my conditions and what's my choice of methods to solve. And the second C is calculate. Don't forget to show your work. And then the last I is interpret in the context of the problem. All right, let's work on this problem. The number of flaws per square yards in a type of carpet material varies with a mean of 1.6 flaws per square yard and a standard deviation of 1.2 flaws per square yard. The population distribution cannot be normal because a count takes only whole number values. An inspector studies 200 square yards of each of the material, records the number of flaws found in each square yard, and calculates X bar, the mean number of flaws per square yard inspected, in his sample. Find the probability that the mean number of flaws exceeds 2 per square yards. Follow the four-step process. That's our ICCI. All right, your first step is to identify the problem. What's the probability that the mean number of flaws per square yard of carpet is more than 2? All right, remember, the mean of the sampling distribution of X bar is 1.6, which is the mean of the population, mu. That's 1.6 flaws per square yard. Remember the conditions. First of all, the 10% condition is there must be more than 2,000 yards of material in the population, so our 10% condition holds true. So if that's true, which it is, then the standard deviation of X bar is equal to 1.2 divided by 200, which is our square yards, which is 0.085 yards squared. And the second condition, since the sample is large enough, remember the central limit theorem, it's larger than 30, 200 is larger than 30, we can use a normal distribution. Our conditions are good, so we're good to go. Remember to show your work when you do calculations, probability that the mean of X bar, the mean, is greater than 2 is equal to probability that Z is greater than 2 minus 1.6 over the standard deviation of 0.085. Notice the giant Z value, so it's essentially 0. We won't say 0, but essentially 0. And there's a picture with the numbers on it. So our interpretation in the context of the problem, there's almost no chance that the number of flaws in our sample is greater than 2 if 1.6 is a true mean. And remember, it's 2 flaws per square yard. All right, you ready for a staring contest? Let's do it. Rachel wins.